Okay, am I on? Can you guys hear me all right? Yep. Great, okay. Thank you so much for having us. We really appreciate it. See, all right, and the technology works, okay. First of all, before I start, let me ask a little bit about you all. How many of you know absolutely nothing about solar energy, or just, okay. How many of you know a little bit and are interested potentially in solar energy for your home? Okay, fair number. How many of you know a fair amount about it, pretty extensive, and want to ask, want to quiz me pretty extensively? All right, okay, great. Excellent. Okay, so a pretty good range. That'll help me in terms of how much I spend time on different things. This is what we're going to go over, and feel free to ask me questions. There'll be time both at the end and during my presentation. We're going to cover kind of the basics of solar energy. We're going to focus on photovoltaics, basically solar electricity for your home today. I'll touch on some of the other technologies, the process for installing a system on your home. And in that context, questions to ask and things to look for when you're thinking about solar energy. We're going to go over some examples focusing on the economics of solar. And then we're going to go over some interesting solar energy myths, or some things that people think about that may or may not be true. And then, of course, we'll have time for questions and answers. There are two basic types of solar energy. There's a lot of talk in the marketplace about solar technologies, and it's really a fascinating area for research and development today, which was one of the reasons what makes it so interesting. And just to give you a little bit of background about myself, I actually learned about solar energy in high school when I was on the debate team, which is kind of an embarrassing secret. But in order for me to start a company, though, I did, as Joe mentioned, I published 2 white papers. I did an extensive amount of research. And before I bought our fairly large solar energy system for our home, we have a 16 kilowatt system at my home. And that's because our house is kind of large, and it was built before anybody thought about the idea of energy conservation or building a home with the idea of energy efficiency, as you can tell. I interviewed over 25 solar installers and dealers. And believe me, if I weren't thinking about starting a company and getting into the business, I definitely wouldn't have gone through that process, and none of you should ever have to do that. And that's part of the reason why I founded Ready Solar, because nobody should have to go through that. There are 2 basic types of solar energy, basically. There's solar electric, and I break these into 2 categories. There's photovoltaic, crystalline silicon, which is most of the regular types of panels that you see today, and those are the types of panels that are out on top of the carports out in the parking lot. There's amorphous silicon, which is confusingly called thin film, and it's the kind of flexible panel that often is rolled down on metal rooftops and so forth. And then there's the new kind of thin film, which is either a different kind of element entirely from silicon, or it's silicon mixed with other kinds of elements. And sometimes the benefit is that it can achieve higher efficiency, or it doesn't use silicon, because currently there's a shortage of silicon, which is kind of ironic because of the abundance of silicon in the Earth's crust. But anyway, there are a variety of technologies, many startups, which I'm sure you've heard of, that are working on some of these thin film technologies, which use a much smaller amount of substrate to create electricity. The problem with this kind of amorphous silicon is, or the benefit of it is, that it can be flexibly used. It requires a plastic substrate, so you don't. It can be much more inexpensively created, however, and it uses less silicon. However, it's less efficient, so you need about twice as much of it in terms of area as you do a traditional crystalline silicon panel. So if you have a lot of area, it could be a beneficial solution for you. But if you have a rooftop, typically a residential rooftop, unless you have a huge house, it's not going to work for you. Concentrating solar is, it actually uses photovoltaic cells in a much smaller quantity, and they actually use parabolic troughs to concentrate the solar rays to generate the electricity. I'm not going to talk about this at all today. There's also a lot of interesting startups in this area. Solar thermal, as you're familiar, heats pools, also is used for domestic hot water heating, radiant heating in homes, and so forth. Solar thermal today for pool heating and domestic hot water can do wonders for your home. In the 80s, there were a lot of unscrupulous dealers who put up fairly poorly designed systems, which then broke down and caused a lot of roof leaks. And that's when you hear people say, oh, solar is really unreliable and bad, that's probably what they're thinking of. The dealers that you work with today, for the most part, do really well engineered and designed systems, and you pretty much don't have to deal with that And you can get very economical and great payback on these systems. They're about 40% efficient, which is actually way better than pretty much any electrical system of any kind, solar or not, that you're going to get. I'm not going to be dealing with that today. I'm just going to be focusing on photovoltaic. Any questions so far? Mm-hmm.
I'm actually interested in both because we ended up with a pool, and I'm actually interested in both because we, in our new house, that we have a pool and we have a house.
Right.
So I really want to figure out how to trade off between the two.
Good question. The question is, I'm interested in both. I want to heat my pool, and I also want electricity. And that's often a question that people have. They get interested in one, they put something up on their roof, and then they're interested in another. And that is actually a goal that a number of solar companies have, is how do we manage to meet both needs? And down the road, that's a product that we actually hope to offer as a combined solar thermal electric product that basically uses the same roof space to provide both benefits. It's a little bit more complicated than it sounds. Basically, with some good planning, you can provide both. And basically, it's mostly space management. And you might end up having to use some of your yard and some of your roof, or just figure out. Solar thermal is a little bit less sensitive to exactly where it's placed on the roof, as opposed to solar electric. And if you find a good provider or two good providers, or somebody who does both, they can give you a good installation that'll meet both your needs. And also, pool pumps actually use up a ton of electricity. We have a pool, which is one reason why we have such a ridiculous solar array. And that's something to think about. Some of the biggest drivers of solar electricity demand are pools, air conditioning, and teenagers. So just on the electricity side alone. I'm not going to spend a ton of time. This is your typical venture capitalist kind of slide, but solar in the US is growing hugely. Part of it is because it's growing off of a tiny, tiny base, but there is a lot of demand, both because of people's growing environmental concerns and the fact that the cost of electricity is skyrocketing, mostly because we're cluing in, like the rest of the world, that the cost of energy is expensive. But there's been a ton of investment in solar technology because of all these things, and we're seeing a lot of growth. How solar energy works. Basically, you have solar panels on a roof, or they can be mounted on the ground in your yard, on a roof, on a ground mount rather. The solar panels, the silicon actually, when they're arranged properly in two different layers, they create a semiconductor which produce direct current, which is then converted to alternating current by the inverter, which is typically mounted on the side of your house, somewhere, doesn't have to be, but somewhere near your electric meter. Grid-tied systems, which is typically, that's what you get rebates for and so forth. There are public policy reasons for that. We're trying to offload the load on the grid, basically, with distributed power. They allow you to use the utility grid as a battery. Why not have batteries? Well, batteries are a pain in the neck to maintain. You have to replace them every 7 years or so. You also have to balance your electric loads inside your house very carefully if you have batteries. Off-the-grid living sounds great, but it's actually kind of a pain to engineer and live on. If you use the grid as your battery, that means that whenever it's cloudy, raining, or nighttime, you can just pull power off of the grid, and it's not a hassle at all. And the other benefit of that is economical. Net metering, means you're able to sell any excess power you produce back to the utility. Now I have this qualifier, up to a point. In California, you can sell any excess power you produce up to the point that you zero out your bill. This is something that was put in to protect the utilities from lots of people putting in so much solar that they were basically becoming individual utilities. Now, of course, all of us don't have the money to do that, so I think it's kind of an unrealistic concern on the part of the utilities. So what happens then is if you buy, in effect, too much solar energy or too many solar panels, you're basically making a donation back to PG&E or whoever your utility is, like they need it, right? So that's basically how solar works. Any basic questions on this?
Is that just a California rule?
It's a rule in California and some other states, but it is a state-by-state rule. I eventually expect this might go away, and it's purely a political consideration, basically. And it's a question of lobbyists, and there are a lot of rules like this which have gone back and forth in favor of consumers versus the utility. This is, I don't need to spend a whole lot of time on this, just statistic. Electricity rates in California on average have increased about 6% per year over the last 25 years or so. Nationwide, it's an average of about 3% per year. In the Midwest, for example, where there are other places where there's a lot of nuclear power in the grid, that tends to bring the average down. But places like the West Coast and the East Coast, where you have much higher average rates of electricity, the increases tend to have been a lot higher. Which means that solar energy, ironically, is a much better deal for us on each coast. Let me ask another question of you all. How many of you are interested in solar energy for basically environmental reasons? Okay, great. How many? Oh, well, okay, I'll get to that. And how many of you are interested in solar for purely, or for mostly economic reasons, just how much money you can save? Okay, and how many of you are interested in solar for both? Okay, pretty good. And of course, a lot of us, it's both, right? Or some mix of the two. Obviously, for you as an individual, it does lock in lower electricity rates over the next 30, actually even 40 years potentially. And it's a very low maintenance cost. You basically have to hose off your panels. You might have to replace your inverter after about 10 or 15 years. For the individual in the community, obviously, it's a renewable resource. It's clean. It doesn't produce smog or noise. It does strengthen our electrical grid. When you have distributed power, meaning power produced at your location, that means it doesn't produce the need to increase our electrical grid or capacity on the grid and so forth, distribution costs. And in fact, in one of the papers that I wrote, one of the biggest social benefits in terms of cost benefits to the taxpayers was the lack of need to increase grid or upgrade the grid, basically, or the ability to delay those costs. It was billions and billions of dollars. It was like $6 billion, which obviously as taxpayers is a pretty huge benefit, or as ratepayers. Mm-hmm.
What about the impact of manufacturing the actual equipment? Is that figured into this in terms of the benefits of solar energy?
Yes, there have been studies on that about the the environmental benefit or the energy impact and all of that, and especially when you compare to other energy methods, coal-fired plants and that sort of thing. Solar power, I don't recall the exact statistics, but the energy payback is very positive. You pay back on solar panels very quickly in terms of the energy put in to produce them versus the energy that they put out. So good question, though. And obviously, it increases our energy independence. No matter where you are on this whole, Iraq question, the more energy we produce within our country, obviously, the less reason we have to do stuff overseas. Quick thing on market research and trends. The research that we've done for both installers and builders as well as homeowners is that we're kind of in the Model T stage of solar in terms of, or it's like probably a better analogy is it's like the PC industry in the 80s where, you kind of have to cobble together parts to get a working system. And more people are saying, hey, I want it to be like an appliance. I want it to be like a refrigerator or a hot tub that I can plug in. I want a standard thing. I want it to look nice on my house. And I don't want it to be, some sort of mystery kit that I hope somebody can put together competently on my house. And that's where, where all sorts of systems, home systems, electronics and so forth have gone, and solar energy systems are going in the exact same direction. That's all the market research that we've proprietarily researched, and we've seen it corroborated in other third-party research as well. So steps for installing solar today. It's still a multi-step process, but we're working, and other companies are working to shrink those down and make them more user-friendly. First, determine if you're a good candidate for solar. Some of these are, you really need to have a residential electric bill, and that's just electric, not electric and gas combined, of $75 a month or more. The higher that is, obviously, the better candidate you are for solar. It should be you should have an unshaded roof area or area in your yard if you're considering a ground mount for at least 4 hours a day. The less shade you have, the better. How do you determine that? Well, you can just observe your yard if you have time. It helps to look at it over the whole year. Well, that takes a long time. One of the ways you can do it is you can have somebody come out with one of these devices. This is a solar pathfinder, and if any of you are interested at lunchtime, I can show you how one of these things works. It's incredibly simple, but it shows you the shading over the entire year. So you don't have to, do a solar study over a whole year. You can just pretty much determine it in about a minute, which is great because looks can be deceiving. What looks like is unshaded now could be completely shaded during the middle of the summer when you actually would have most of your solar production, and that's very important to know. But basically, as long as you have a minimum of 4 hours a day, you can do it with solar. You want to have a roof that's facing south or southwest. Next best is west or southeast. A slanted roof is better than a flat roof, although there are commercial rooftops that have flat roofs all the time. A lot of these things, if you don't have these ideal situations, you'll just get a lower rebate, which means your payback time will be longer, but it doesn't mean that you're just completely out of the ballpark for solar. Completely out of the ballpark for solar would mean trees completely on top of your house. And really, it comes down to your own personal considerations. If you are completely committed to having solar, you may get a lower rebate, or you may need a smaller system just because your house conditions aren't great, but you could still make it work. And I would ask a lot of tough questions to an installer who is saying that you can install a huge system if it just doesn't look like it's going to make sense. Also, if you have partial shade in some area, it's worth it to go with a smaller array that avoids the shade than go for a bigger array, because the shade will actually detract from the overall performance of the parts of the array that are even in the sunlight. Then consider your budget. That's probably the two things that are really the biggest considerations of how much solar you should buy really are your own budget and the amount of roof space you have. A lot of companies, the first step they'll ask you to do is say, get out 12 months of your electric bill and we'll calculate all this stuff. Well, before you even do that, think about how much money do I want to spend and how big is my roof or my yard space if you want to put it on the ground. Because even if your electric bill is $1,000 a month, if you only have a tiny roof, or if you're only willing to spend $10,000, that's the end of the discussion right there. And then you need to, after you have answered those two questions, then you do need to think about how much electricity do I use, and then what is your rate structure? And do you have the infamous pantyhose chart? We call this our pantyhose chart, or our fruit of the loom underwear chart, because when I was doing my research on solar, the question I would ask, the question that everybody asks is, well, how much solar do I need? And nobody would answer this question. It was, and we have long discussed how, when you buy underwear, right, or just like whatever at Target or whatever, there's those charts that have, my height is this and my weight is this, right? And then you look in the middle and there's like, your size A, B, C, D, right? It should be just like that. And it's not quite that simple, but we've developed a pretty, well, okay, it doesn't look simple at all, I know, but it's, we're working on it, but it's a lot simpler in that once you go through these steps, you can figure out, okay, when I figure out how much electricity I want to eliminate, then I can determine, okay, this is how many kilowatts roughly I need. And based on that, then you can, and it has to do with what your rate structure is from your local utility. Now let me ask another question here. How many people are PG&E customers? Okay, how many are Palo Alto utility customers? Okay, how many somebody else, like Santa Clara? Okay, all right, so mostly, Palo Alto is a flat rate utility. PG&E, as we all know, has the tiered utility rates. With PG&E, what you want to do is cut off those top tiers. The more expensive, the more you use, the more expensive it gets. With Palo Alto, since it's flat, it really, it doesn't, it's pretty much determined by your budget and how much you want to eliminate it with solar. But the idea here is, what we've done is we've identified, okay, if you want to eliminate this many kilowatt hours per month of usage, this is how many kilowatts of solar you want. And this is available to look at, and we've got some handouts here for later. But basically, once you've decided that, and that's really up to you, and we'll find a lot of installers will want to push a lot of solar on you, but it's really not, not necessarily in your interest, because as I said before, if you buy too much solar, you're making a donation to the utility, which, while it's contributing more solar to the environment, reducing CO2 and so forth, which is a good thing, if you're going to make a charitable donation, you might want to make that to a different organization environmentally. I mean, that's totally up to you. Some people do decide to do that. Choose your solar vendor and arrange for financing if you want, and we'll talk about that. Elizabeth will talk about that in a moment. And then you go through, you have people come out and make site visits, and you get contracts and so forth. Then you have your installation, which typically doesn't take very long, maybe like a week, maybe 2 if it's a huge system. Then you're into solar energy production. And an important note, you do not need to cover your whole bill to make a positive benefit for you economically at all. In fact, if you're a PG&E customer, just knocking off that top tier of usage could be a very small percentage of your actual kilowatt hours, but it could make a big impact on your bill. And obviously, if everybody does a little bit from an environmental standpoint, it's like recycling. If everybody recycles a little, it has a big impact. And then submitting the paperwork to get the rebate. Your installer should help you a lot with that. And it's, you know, it's like taxes. It's a pain in the neck, but everybody has to do it kind of thing. But your installer should help with that. I've talked about a lot of this already. Size of the system, I think I've covered this. If you want to basically eliminate your top tiers if you're in a tiered pricing situation. Cost of a system, typically for residential systems, range from about 10 kilowatts to 50 kilowatt, $10,000 to $50,000 or up, depending on the size of your home. Aesthetics, okay. Let's see if I can do this. No, damn. Oh, right, sorry. Okay.
There you go.
I'm kind of a PowerPoint troglodyte here. Elizabeth is training me how to do these things. Okay. This is one of the few plugs I'll make for Ready Solar. But a lot of people totally buy into the idea of solar economically, solar environmentally, but you know, either they, their spouse, their neighbors or whatever just completely hate the looks. And this is what a traditional solar system looks like. And you know, it's a kind of it's an economically rational issue because you know, that if your home is your largest asset, which for some people it is, you don't want to detract from its curb appeal. So you know, you might want something that's more aesthetically appealing. You can do something like these are Ready Solar systems, or you can do solar integrated tiles, which are flat. They're built into the roof. That makes more sense if you're replacing your whole roof or you're looking at new construction, which you know, obviously it's built flat into the roof. So you have a much more attractive look of the system, and which is a big issue for people. So something to consider. The other things are, what kind of incentives do you have? Do you get rebates? Right now, there's a $2,000 federal tax credit. Maybe in this administration, probably not in this administration, but hopefully in another administration, they will extend that federal tax credit to be up to 30% of the value of the system. And also, does your utility offer net metering? Palo Alto and PG&E do. Then also return on investment. Those are your own criteria. You know, how important is that to you? At what time scale do you want to earn your money back, and so forth? How else can you invest your money? Are you considering that at all? And then what environmental goals? Some people care a lot about that and want to do solar no matter what. Some people don't care at all. Yeah, I swear I don't have an unauthorized copy of Vista, but okay. Okay, I think I've covered this as well, but basically what solar enables you to do is, if this is your typical tiered electric bill with PG&E or another similar utility, you have a high marginal electric bill before solar. And then once you put in your PV, basically what that does is that lops off the top tiers, even if you're not covering your whole bill, because covering your whole bill, you're actually going to be paying for electricity that costs less because the investor-owned utilities are required to offer that electricity at actually below market rates. But what it does is it whacks off that electricity, which is really high and expensive, and that's where they're going to be increasing their rates over the next several years. So your electric bill, even though your usage, your actual kilowatt hours might not be that high in that area, it's the dollar value is very high. So that's just a graphic representation of what I was talking about before. So now we're going to go through some examples, and I will hand it over to Elizabeth, who's going to talk.
How does this thing work?
This is forward, and that's back. And so that will just go through the build.
Okay, great.
All right.
So I'm going to go through some examples to give you an idea of what the economics are associated with installing a solar energy system. So our first example, homeowner number one is a PG&E customer, and as Meredith mentioned, PG&E has a upward tiered rate structure. There's 5 tiers. So the objective for this homeowner is to eliminate their top tiers, which are 4 and 5, from their usage. They have an average monthly bill presently of about $120.40, which equates to a monthly usage of 567 kilowatt hours. They have opted not to use financing to pay for their solar energy system. They're just going to pay for the system up front. And they're going to install a system that will provide 2,500 kilowatts of capacity. The cost associated with this size system, including sales tax, installation, taking into consideration the PG&E rebate and the federal tax credit, is about $15,000, a little bit more. This size, whoa. This size system will provide solar energy production of about 300 kilowatt hours. And that's energy that the homeowner is not having to purchase from PG&E. And as a result of that, they can expect an estimated monthly PG&E savings of about $86.53. So that's significant. And this number is not taking into consideration the projected increase in retail electricity rates going forward. So this number would actually increase with time.
It's not 25 kilowatts.
Sorry, you're correct. It's 2.5. I stand corrected. So you're going to see that again.
When a system is like rated at 2.5 kilowatts, it doesn't actually produce that.
I'm sorry, when it what?
It's like if this system is rated at 2.5 kilowatt hours, it doesn't actually produce that much power.
If I can actually interject, is this is our, you were using our
Right.
2500?
Right.
The question was when it's rated at. Actually, I've got my thing, so I'm okay. The question was when it's rated at 2.5 kilowatts, it doesn't actually produce that much. This is an area of significant confusion with solar because there are DC watts and AC watts. DC watts being the direct current, AC being the alternating current that we're all familiar with. The reason why you'll often see things rated in DC watts is because they're a smaller unit, or so if you divide things by that, the price looks lower. AC watts obviously are more what we can relate to in terms of our own electricity bills. In this case, when you were calculating the kilowatt hours, you used AC watts, right? So the short answer to your question is yes. You always need to ask that question: is this AC or DC? And typically, in order to get your rebate, you have the installer needs to convert everything to AC. And there's actually the California Energy Commission, which regulates all this. They actually created a separate rating system because solar panel manufacturers were, when they would say, okay, this is for example, a 200-watt panel. That was, it would produce 200 watts if you were at 0 degrees C with basically with lighting conditions producing 1,000 watts per meter squared. Basically perfect conditions, which would never happen in your yard. And so what the California Energy Commission did is they actually set up separate testing conditions in which they now subject all the solar panels to, which are sold in California. So anything that you buy has to be, in order for you to qualify for a rebate, has to be listed on the CEC website. And they have, for example, if it says, for example, the panels that we sell are, they're listed as 180 watt panels DC, but when their actual AC watt rating is 159. And that's based on real world temperatures and et cetera, and real world lighting conditions. And so what we've done is when we look at what output they're likely to produce, we use the CEC numbers. And then they also have to account for what inverter you're using, because the inverters also have a little bit of efficiency loss. They're anywhere from 90 to 96% efficient typically. And so you have to multiply that lower panel rating times whatever the percentage of the inverter is, and that gives you your watts. And then that's what your rebate is based on, plus a whole bunch of other factors. Is your roof south facing and all this other stuff. So anyway, when Elizabeth was calculating the rebate in the net cost, that's all included in there. Does that kind of answer your question, or does that leave you more confused?
So is that 2.5 AC or DC?
Sorry?
Is that 2.5 AC or DC?
That's DC. That's DC, and it's about I believe. And it's about I have to pull out our price list and look. It's about 2.2 kilowatts DC.
When you divide 300 kilowatt hours by like 720 hours in a month, and you have a number close to that.
Right.
I mean, you get like 416 watt hours if you do the math.
I'm sorry, what?
This is, generally there's a peak hour, number of peak hours a day, which is like 5.4 or something. That's
Right.
what you divide this by. So this comes to like whatever, 10 divided by 5.4 is the number
Typically, the calculation would be you take the number of kilowatts times 5 or 5.5 or 5.4 or whatever. Typically, in this area, it's typically about between 5 and 5.5, and then times 365 days, because 5.5 is an average for the year, because you'll get many more in the summer and much less in the winter.
Should I go on to the next example?
So does that? So are you questioning the 300?
Well, it makes sense now. They only use 6 hours a day.
Yeah. Okay, did you have a question?
5.5.
Okay.
Okay, so I'm going to go on to the next example. Homeowner number 2 is a City of Palo Alto Utilities customer, and as Meredith mentioned, flat rate structure. My understanding is that presently the rate is about 7 cents per kilowatt hour, and I know we have some Palo Alto residents here, so let me know if it's something otherwise. The objective here of this homeowner is to add some solar, and stay within their $15,000 budget. Presently, their average monthly bill is pretty low. It's $39.69, and that's because of the flat rate structure, and they're only paying 7 cents per kilowatt hour for their energy from the utility. They've also opted to not use financing to pay for their system. Solar capacity that they plan to install in this case is 1.25 kilowatts of capacity. So again, I apologize for the error there. The cost associated with this size system, including sales tax, installation, taking the rebate that the Palo Alto Utilities provides, as well as the federal tax credit into consideration, is about $7,000. And this size system will provide monthly solar energy production of about 150 kilowatt hours. So taking into consideration that that's energy that this homeowner actually will avoid paying the utility for, this homeowner would enjoy a monthly savings of about $10.50. So you can see there's a really significant difference between an upward tiered rate structure and a flat rate structure. So, basically same amount of energy usage to begin with. The Palo Alto resident has opted to install a little less capacity, but even if the Palo Alto resident installed as much capacity as the first homeowner, their monthly savings would only be about $20. So you can really see the difference between the different types of rate structures. And then finally, homeowner number 3, another PG&E customer. Their objective also is to eliminate those top tiers. And just to give you an idea, Tier 5, the cost per kilowatt hour is actually 37 cents as compared to 11.5 cents at the baseline. And they also want to use financing to pay for their system. Presently, their average monthly bill is almost $200, which equates to a monthly usage of about 781 kilowatt hours. As I mentioned, they are planning to use financing to pay for the system. They plan to install 3.5 kilowatts of solar capacity, and the cost associated with this size system, including sales tax and the installation, and they're actually going to finance the entire cost of the system up front. So the federal tax credit and rebate are not taken into consideration here in terms of the total cost. $27,918. That size system will result in monthly solar energy production of about 450 kilowatt hours. And by not purchasing that amount of electricity from PG&E, this homeowner will enjoy monthly savings of about $150. So that's pretty significant. And based on a couple of assumptions relative to financing, their monthly payment based on using the financing would be $140. So you can see that they're actually putting the money that they otherwise would have been giving to PG&E to take care of those higher tiered usages towards investing in a solar system and a solar energy system and really an asset. And once they pay for that, they will actually start to enjoy, something more than $150 per month in savings, especially as electricity rates continue to increase.
And another thing I'd add to that is these financing vehicles are all home equity loans, so the interest that's paid on these is all tax deductible, assuming you haven't already maxed out your home equity loan. I think you're able to take out. I think it's up to. I can't remember. I don't recall what the upward limit is, but you can deduct the interest on home equity loans, so you can also then get additional tax savings off of this. So your actual cash flow, you're actually more cash flow positive than this appears here. Mm-hmm.
Have you seen whether or not the systems are increasing the value of home, maybe up to the amount of money that you put into the system, or if they're, what's the effect of that on the value of home?
In California right now, and actually. I know in California for sure that the solar energy systems are property value exempt. So they're not supposed to impact the value of your property. I mean, are you asking if you sell your house? Right. There have been studies which have said that basically the argument is that if you reduce the operating cost of your home by, for example, putting on renewable energy, that sort of thing, that you'll recoup that 20-to-1. Now, that sounds great, but however, if it's completely ugly on the front of your house, let's face it, that's just not realistic. I think it's a very subjective thing. I think as more and more people are viewing solar as a positive thing, if it's aesthetically appealing, then I think it'll be a positive. If it's ugly, it's just not going to fly. As electric rates increase, it's going to become more and more important with people. Some empirical examples are, for example, in the Sacramento area, where the utility up there has been very proactive in encouraging home developers of developments to put in solar. Developments like literally, across the highway from one another, developments with solar have sold out much more quickly and at slightly higher prices than developments without solar. So things like that. And we're seeing that in this housing slump, for example, homes with solar tend to sell, multiple days quicker than homes without solar. Not necessarily at a price premium, but we're in a rough housing situation. So, but selling days quicker, that's time is money. So I think as we see more data points, because there's literally so few houses today with solar, that all those differences in terms of comparables and stuff, it's very hard to get some good comparables of homes. I don't think there's good data, and I think if somebody comes to you, I've seen a lot of quotes that say it's going to increase your home value by $45,000 or above the cost of the system. Frankly, I just don't believe that. That's also like the person who comes to you and says you can deduct the entire value of the solar system because as a business, because you have a home office in the back room. I don't buy it. I think over time, I think if you do a nicely installed system and so forth, I think it will benefit you. But you do have to take all those things into consideration. Mm-hmm.
On homeowner 3, they got $8,500 of credits and rebates. What about 1 and 2?
Those were actually taken into consideration in the overall cost.
Oh, the question was homeowner 3 got $8,500 of credits and rebates, but what about homeowner 1 and 2?
Subtracted to come up with these two numbers, but because number 3 is financing, they have to finance the entire upfront cost, because they're not going to receive the rebate and the federal tax credit until sometime later.
And sometimes, depending on how your installer works, sometimes the installer will carry the rebate, so you might not have to finance the rebate part. Okay.
So, you said that PG&E's rate is 11 cents kilowatt hours?
Baseline.
Yeah. Do you know the rate of increase over the next 3 years? Is it planned already?
They haven't published. The question is, do we know the rate of increase of PG&E's rates over the next several years? They haven't published what those rate increases are going to be. They've gotten a package increase over the next couple of years of, I think it's like $600 million, but they haven't published exactly in what rate tiers those are going to be. The warning has been that it's going to hit large residential customers the heaviest, because commercial customers have complained heavily that they're all going to move out of state and that they've already been hit heavily. They are legislatively prohibited from impacting the smaller rates. Also, what they've done in some cases is the baseline rate, the cheap rate, stays the same, but the number of kilowatt hours that you can use in that rate before you get bumped up to the higher rate shrinks. So it's still 11.5 cents, but you only can use 100 kilowatt hours before you get bumped up. So there's lots of different ways the prices can change. If you're ever curious or you have insomnia, you can go to the PG&E website, and if you search under tariff, electric tariff, you can actually find the rate schedule and see exactly, read all about it and see how electricity is priced. It's kind of like airline price schedules. But it's pretty arcane, but it's also, as you can see, pretty complicated, and there's lots of different ways to extract money from selling electricity. So anyway, electricity is projected to increase, and they typically publicize these things. They're regulatorily required to publish the rate increases several months in advance, and then there's a public comment period and so forth. But usually once that's done, it's pretty much a done deal. Okay, some solar energy myths. Solar's not cost effective. Well, it is if you size your system correctly. And I think we've covered that. It depends on which utility you're at and what your objectives are. It definitely can save you money. And especially if you look at, we didn't cover this in detail, but we've got actually a great article by a gentleman named Andy Black, who's a solar financial analyst, who's done tons of analysis of how, whether or not solar saves you money. And if you look at the rate of increase of electricity over time, and the idea of investing in a solar system around now, you can really see the benefits of fixing your electric costs. And anyway, we've got that article is up on our website, and we've also got copies here today. One issue that I think is important to address is the idea that you need to get the most efficient panels. Some people will try to sell you this, and there's also kind of this idea that you need to get the panels with the highest efficiency, whether they're 14% or some manufacturers advertise 20%. That's in a lab, not in reality. And really, the market is pretty efficient. The higher the efficiency of the panel, the more expensive it's going to be. So you're paying for that, and in many cases, you're paying more for that. It's like a fancy car. And unless you have a tiny, tiny roof, you really, if you have the space, it's better to buy a lower efficiency panel because you're just sucking in sunlight. And there's no benefit to having more efficient panels. You're not getting any more energy out of it. You're just pulling the same amount of electrons. And if you have one more panel, that will just bring in the same amount of electrons. And if you have one very efficient panel instead of two medium efficient panels, it's much more, it's much smarter economically to have two medium efficient panels that cost a lot less than one really high efficiency panel. So don't let anybody sell you high efficiency panels unless you really, really need them because you only have 10 square feet of roof space. Something I've seen advertised a lot is, so-and-so has a $5 electric bill thanks to such and such. Well, yeah, every time you get a solar energy system, you get, for the first 11 months of the year, you get a $5 electric bill. But that's because of how net metering works. You get a net meter, you get a $5 electric bill in your regular, say, PG&E envelope, but then you also get this really arcane statement. It comes in an envelope that looks like this. And actually, I have to give PG&E credit. They've improved. Last year, when we first got our system going, this thing was like 10 pages long. And it had every meter tick on it. And now it's only like 3 pages long. But it's called a true-up statement. And it talks about, it shows what the meter did and the difference between how much went out versus how much came in. And you might be tempted to say, and throw it away. However, at the end of the year, in December, you will get a comparison bill, which will then tell you how much you owe the company if your solar wasn't enough to cover your entire bill. And if you say only have a couple of kilowatts and your usage, say before you got solar was say $300 a month or something, you could end up owing a few $1,000s to PG&E. So don't be surprised, even though you had a $5 electric bill all during the year. And that's just the way it works. And if you call PG&E and say, what's this? They'll just say, well, you just need to put money aside during the year. That's the way it works. That's nothing wrong with your solar. Your solar's been working fine. That's just how PG&E works, and most other utilities as well. So don't be surprised. It's best to wait for the new technologies. This is another with all the press about thin film and all the startups around here and everything, there are a lot of people who, think just like, new computers coming out every 6 months and stuff like that. Why not wait for the new ones? Well, the reality is a lot of these are 5 to 10 years away. And in fact, a lot of the thin film companies who, even were saying we're a month away from production. First of all, a lot of these are aimed at commercial markets and not residential markets. And secondly, a lot of the ones who thought they were a month away from production, that was a year ago. And they're still not in production, because a lot of this stuff is really, pretty different from what's being done now. So if you are looking at getting a return on your own investment, it's probably wise to go ahead and do something now. Unless you're just interested in studying the technology and, you didn't buy a microwave until 1990. They really are farther out than it sounds. Covered this. You don't need to cover your whole electric bill to make it worthwhile. Even a couple of, 1 or 2 kilowatts, if it fits your needs, that's what you should do. Also covered this. You don't need perfect conditions. Your roof doesn't need to be in full sun all day, perfectly south-facing, et cetera. You might get a lower rebate, but again, that'll just affect some of your economic payback. If you really want to go solar, you can. And then, PV is hopelessly ugly. Chances are you wouldn't be in this audience if you thought that. So, that's also, there are different options out there to make PV look better. So, any other questions, beliefs, or whatever that I should cover?
How does the efficiency degrade over time of the cells?
I'm sorry?
How do the cells degrade over time, the efficiency?
How do the cells degrade over time? The efficiency. Over the 30 to 40-year life of the cells, they are warranted, they're guaranteed by almost all manufacturers to retain 80% of their efficiency, which that sounds like a pretty big drop, but that's over 30 or 40 years. So it's a pretty slow degradation curve. And actually, interestingly enough, there are some studies that some of the national energy labs are doing, which indicate that curve actually happens like right when they come out of the box. So it drops like 15%, and then it's like. So, but interestingly enough, that research really hasn't been quantified yet. So, if that's true, that's kind of bad news when they come out of the box. But then that means it's pretty steady. It's almost like a physical phenomenon that just happens, and then they're just there, which might mean that is taken into account by the testing that's done by the Energy Commission folks, and maybe that's the reason for the drop between the lab. Between the, what the manufacturers claim and what we actually get.
So there are different versions of those panels. The old ones are not as good as the new ones. And as you said, some companies say we'll have better ones tomorrow, and the tomorrow keeps moving. Right. But I also understand that it depends on how much you're willing to pay for the panels. So for residential, do you have actually better panels that cost more if you have a small roof? And then the question again that you kind of half answered is the ones who are promising better tomorrows. Are we talking a couple of percent? Or are we talking 10% more or something significant?
Very good question. The question is, are there better panels if you have a small roof, and do they cost more? And then with the ones who are manufacturers who are promising something better, is it 2% or is it 10%? In answer to the first question, there are some panels that are higher efficiency if you do have a space-constrained situation. And a couple of brands that I'll mention are Sanyo panels. I think those are the highest efficiency panels on the market. The reason for that is they actually have a layer of amorphous silicon as well as crystalline silicon, both types of silicon in the same panel. And you pay more for that, as well as SunPower panels. Both those panels are also pretty nice looking, so you get an aesthetic benefit as well. You do pay more, a premium for that, but you're also getting a premium in production. So if you have a limited space, it's probably worth it to go for those types of panels. The companies that are saying we're going to have something better, soon, those tend to be companies that aren't in production yet. It's kind of the old, if you say, we've got to have a great version that's coming out, you don't want to kill your existing product line, having people wait for the new product line. The companies that are saying we've got to have this great product that's coming out and it's going to be, revolutionary, et cetera, et cetera. Those are the thin film companies that are planning production. Those tend to be, again, aimed at commercial markets, not residential. So they're not going to be available for us, for another decade, really. And the companies, the companies that are selling into residential markets now are making slow but steady manufacturing improvements, and those are really, learning curve kinds of things. They're not leaps forward in terms of new, major leaps forward in terms of technology. It's just we're getting smarter and better and more efficient on the factory floor, sorts of things. And you get the same benefits of, as we introduce a new model that might be a little bit better, that means the old models are cheaper. For example, the array that I bought, I got Sharp 160s, which are actually derated 167s, but I got a much better price on them. And it was a ground mount in my yard, so I didn't need, I didn't have a space issue. So it was much more worthwhile for me to get 160s that were a little less efficient. I had space, so I put them in and I got a better price. So it just made a lot more sense. Uh-huh.
So like my in-laws, they live in Texas and they live on a farm, so they got lots of land, they got south-facing rates. So they'd be a good candidate for solar, but in Texas, hailstorms all the time. So I was wondering just how resilient are these panels to like hailstorms and other natural disasters like in Texas and the...
Great question. How resistant are solar panels to hailstorm? Because that's a very good question that people ask a lot. Solar panels sold in the United States have to conform to its UL 1703, which is an impact test. So they have to conform to, I think it's a half-inch ball bearing dropped from 5 feet or so. I don't know the exact parameters of the test, but they do have to conform to that, which is basically just designed to simulate fairly substantial hail. And there are, when you think about it, the largest solar market in the world is Germany right now, and Germany's latitude is about the same as the northern U.S. and parts of southern Alaska, which gets pretty severe weather. So they, and they sell tons and tons of solar panels there. So they, they are, and also Japan.
There are a lot of problems with people leaving their panels because of hail.
Right? No. It's all, they're all warranted, and they all have to pass that UL test. And that's an internet, and that also conforms to another international standard as well. So yeah, hail is, they've definitely covered hail, because they have to be on rooftops. So,
Question about inverters. My understanding is that the current inverters, when you lose grid power, they also take your solar panels offline.
Yes.
Which in California, with we're at the mercy of the power companies who decide to do rolling blackouts on us. I mean, that seems to be a completely idiotic technology. And electrically speaking, there's no reason for that. There's got to be some, cheap, effective grid sensing technology that can automatically pull your PVs off the grid and allow you to have power in your house. And power how much?
Right. Well, that's a great question. The question is, why do the inverters take your solar panels down when your power goes out?
I understand the safety issue, but at the same time, it seems to me that there's existing technology that should allow you to have your cake and eat it too. I
completely agree with you. Yes, the reason why that is a requirement for inverter manufacturers is to prevent so-called islanding, where if you have a solar array still functioning when the power goes out, if some poor lineman is out trying to fix the problem, he does get fried with electricity being fed back to the grid from your solar array. Totally get that. However, there are tons of people who have generators which automatically come on when the power goes out. Why doesn't that, it's because, anyway. There are two answers. One, you can get a battery backup system, which they are expensive, but there are good ones on the market if that is a big issue for you to deal with that. Although you do have to size what's hooked up to the battery backup and all that. To your point. However, I think that's a great. It's on my list of product innovations, down the road, because it is stupid. Because a lot of people, one of their big issues in solar is, I want to have to not deal with this, especially in California. And I think there's got to be a way to deal with the safety issue, to isolate the box, to keep the power from going back out to the grid and allow people to continue their power. So and you're right, technologies exist because people do have generators. So it's on our list. I think it's, like I said, I think it's stupid. It's on our list. It might be a legal issue. I don't know. I'm sorry.
I just have a question regarding why do you advocate solar over wind power? I mean, wind power, as far as, I know a lot about both subjects, but it has a much quicker energy payback as well as economic payback, and this area does have a good location for...
It has a greater payback depending on where you are. If you're in the Columbia River Gorge in Oregon, I think you're totally right. If you are in, Mountain View, it might not. So wind is much more location specific. Or let me just say, there are places where there are, I think it depends on where you are, and I think there's a broader solar resource in this country, and for me, I happen to pick solar as the horse I wanted to ride. I'm not against wind at all. But I think, and I think there's also a role for many different alternative technologies in our economy. So I'm not, like I said, I'm not against it. I think you do need to, in order for wind to be successful, you do need to make sure you've got a good wind resource.
But I think that's also like one of the kind of myths, I guess, in terms of wind power, that it cannot be used in a lot of areas. It's actually not true. It can be. And I guess a lot of people, solar is a big buzz kind of thing now that people want to include, but
right. Well,
I'm wondering why specifically you chose.
Right. Well, from a startup's perspective, we wanted to focus. That's, for example, why we didn't focus on solar thermal. Even though they seem very similar, it's actually, it's a different technology from an implementation standpoint and so forth. It's different enough that we decided to just focus on residential photovoltaic. So, someday as we grow, we might very well include residential wind. And just for now, we're just sticking to our knitting here, but it's not due to any kind of philosophical opposition to it. And I know there are a number of companies that are focusing on very small residential turbines that require very low and can function with intermittent wind speed kind of situations, which is great, because a lot of people do prefer that profile to solar, and it's which is great. Other questions?
Well, an answer to your question about why does it go off when PG&E shuts down, you have to have a lot more hardware. You have to have a transfer switch, and typically, except at very rare times of the day, you can't power your whole house. So then you have to be able to shed load within your house automatically. Otherwise, the system, the inverter would trip. So there's it's a lot of wiring, and I think that
it's expensive.
Yeah, you're going to pay probably much more for that than the inverter.
Any other questions?
Yes, I've been looking at your company's website. So it seems like you sell pre-made solar arrays.
Mm-hmm.
So what's the cost approximately of one of your module?
I'm sorry, what's the customer?
What's the cost of one of your module?
They range from about $9,700 plus installation, which is about $1,000 on top of that, up to you can spend like $70,000 for a 10 kilowatt, big, humongous installation. So. Well, thank you so much. Appreciate your attention, and I hope I've answered some questions. And it's really a pleasure to be here. Thank you.